So I've had some people ask me about finding areas between curves, and keep in mind when we're talking about math apps, that anytime you're asked to find areas between curves, that you can use technology to do the integrals. You don't need to do the integrals by hand, and you also don't need to you don't need to find the points of intersection by hand. So I'm using Desmos, but I also can always just type stuff into one of the graphing calculators and show you how you could use that to find the points of intersection, to find the integrals and all that. I just like Desmos because it looks prettier. So, for example, we had a problem where it gives you two different functions, and they're not too bad. You've got some little parabola, and then you've got another equation that's a line, 10 minus x, and it wants you to find the exact area enclosed by those two curves. And so that's this zone right in here in between there. And what I want you to remember is that just in general, that if I did the integral from a to b of a certain function, what that's telling me is that's telling me the area between f of x and the x-axis, with the caveat that if it dips below the x-axis, that's negative, and so it kind of counters it out. So sometimes we'll put the signed area in front of that. But the visual that I want you to have is that if I just did the integral of one function, that would give me the area below the whole curve. So if I was doing the integral of the red function, that would give me all of this stuff here. But what I really wanted was just that first part that I shaded in, just the top spot. So what I can do is I can do the integral of the blue function, and that'll give me this zone right there. And so if I did the red minus the blue, that would leave me with that region that I actually cared about. So when you're doing one of these problems, what you need to identify is who's on top and who's on bottom, because you want to do your top integral minus your bottom integral, because then you have that leftover bit. And you want to know, what are my a and b? From where to where am I integrating? And that is either directly told to you in the problem, or it is the points of intersection. Like here, it turns out to be the points of intersection. Desmos is nice, and you can just click on it. So I know that my integral goes from 2 to 5. So I know my answer is going to be the integral from 2 to 5. The top function is my parabola, the red curve, and the bottom function is the blue curve. And there you go. That should give me the integral. Oh, come on. Why is it not integrating? Well, okay, so sometimes Desmos doesn't want to work with me. That's okay. You can do it on here as well. So I'll just show you the same exact steps. 6x minus x squared, 10 minus x. You can see the same picture showing up right there. You see how there's that same interval. To find your points of intersection, you go second trace button, second trace button. Intersection is option 5. Hit enter 3 times. It'll tell you that one point of intersection is x equals 2. Go back to that same menu, second trace, down at option 5. You just got to scoot over, make sure your blinky thing is closer to the other point of intersection. Enter, enter, enter. Now it's 5. Now to get it to do the integral, you can go into your main menu, or you can do it on the graphing screen. I'll do it in my main menu. You go Math menu, option 9 is your integral. I'm going to type in exactly what I had on the what I exactly had typed into Desmos. For some reason, Desmos failed me, so I'm going to go back to good old TI 84. Typed all that in. I guess the answer is 4.5. Okay. So that's one example. Let's look at another example. So on this other example, we've got y equals 2x minus 2. We've got x equals 6. And y equals 36 over x squared. And it wants us to find the area bounded by the x-axis, this line, and this curve. So it wants us to find this zone right here. Okay. What's hard about this is that who's on top and who's on bottom changes depending on what zone you're in. So the way I see this is that I want to split up the region right here. And I'm going to do this region plus this region. Do it as two separate integrals. Okay. So what I first need to find is I need to find what is this point of intersection. And we can find that just by typing it into the calculator like I showed you a second ago. 2x minus 2, 36 over x squared. Let's see if that looks right. Beautiful. Point of intersection, second trace, option 5. Just remember that second trace, option 5. Move my blinker thingy over there. There's only one intersection. I guess I don't need to move it. It finds the point of intersection. The x value is 3. So I know I'm going to do an integral up to 3, where the line is on top and the x-axis is on bottom. This point right here, I could find it with technology, or I can just realize that's the number 1, because if you plug in 1 for x, you get y equals 0. So 1 to 3. And then I'm going to add on to that the integral from 3 to 6, because it told me in the problem that x was 6. And that's going to be the integral of 36 over x squared dx. Really, you can just type it into your calculator to get these integrals, but these ones work out like maybe I should just show you how to do this one by hand. This one on the left is just a triangle. It's not too bad. It's just a triangle where the y value is 4, and then the x value is a length of 2. So 2 times 4 is 8, but it's a triangle, so I cut that in half. So I know this integral is going to become 4. This other integral on the bottom, it's a good reminder that 36 over x squared is the same as 36x to the negative 2. So if you integrate that, you're going to add 1 and divide. And so I get negative 36 over x, like that. And we're integrating that from 3 to 6. So that's negative 36 over 6 minus negative 36 over 3. My pen is failing me. So that's negative 6 plus 12, which is 6. Add the 4, and I get a final answer of 10. So that was a couple problems finding exact area. Please let me know if there's anything else I can do.